your time for the conversation.
My pleasure.
I would like to understand the innovation of PowerCo a little bit more in depth. So maybe to start off with a general question and a personal one, how did you find into e-mobility and battery innovation?
Well, I can tell you 30 years ago almost, my diploma was an electric vehicle. So I made, together with two other students, we made a drive system, power inverter, electric motors and lead-acid batteries. And of course we figured out that the battery is a big issue. I was always in electric drives in my whole career in automotive business. And I did different electric drive systems for hybrids, for EVs and batteries too. And after lithium-ion batteries came into the game, I figured out I have to concentrate on that to make sure we will get there.
Okay, cool. And then a couple of years ago, the interest of VW in the battery sector became more and more, and then PowerCo emerged. And since then, how would you briefly describe the trajectory that PowerCo has undergone?
Well, it was very, very fast. We have designed the concept of producing batteries in-house and developing the technology in-house a long time, and we really were working on the business model long time to make sure it's secured, because we have to be a fast follower. The industry is more than 30 years in the business. They're established players we respect a lot, and these are going already for high scales and good performance, also in cost. So the concept had to be a robust business model. And with that, we defined a standardized product for Volkswagen. It's not only PowerCo.
Which is the unified cell, correct?
Right, the unified cell. Thank you, Simon. That is what we standardized also for the suppliers next to us. And with that, we come to high scale and we get the cost under control. We're robust in technology, so if we can sell the one car but not the other, the cells are the same. We can just take the cells and put them into the other car. What we cannot do if it is different technology.
Yeah, maybe it's a good idea to elaborate quickly on what the unified cell is. So what is its design and what are the key pillars that make it so robust technology?
Yeah, Simon, the first concept or let's say the first idea behind the vision was we have to have a standardized product what fits into all cars. Because then if we bring a new car, the old cells fit into it. If we bring a new technology in the car, we have the battery. If we have the one car what is not selling but the other one does, we have the cells. This was the first idea. Then we were discussing about the design. We were finally deciding for prismatic because it's mechanically more robust than pouch, and you can stack the electrodes. If you do cylindrical cells, you cannot stack the electrodes. And finally, that was an argument because to say we do cylindrical means you cannot stack, right?
Interesting.
Yeah, you have to do jelly rolls.
Yes.
Yeah, so with stacking you are flexible. With prismatic cells you can do winding or stacking.
But why being flexible when you have a unified cell, if I may ask?
You have to be technology open for the future. So the unified cell ends up with even solid state batteries. Yeah, this is the same format.
So it's about the housing, correct?
Yeah. Yeah, okay. And all the production equipment. All the production equipment is standardized. So if we come with a new innovation, let's say dry coating, we just exchange the coater in the next plant, but the rest of the whole system is same. And it's not similar but different format. It's same. We can even use electrodes from the one plant and ship them to the other plant.
Okay, understand. So maybe to understand your innovation process for the unified cell, how long did it take to evaluate the mainly three different options that there were, pouch, round, or cylindrical, and then prismatic? So how long did it take to come up with this robust concept where you are so confident about that it will be replicated millions of times in the future for probably a decade or longer?
Yeah, with stacking and winding has to be possible. We were clear that it is not cylindrical. And if you want to do, a ceramic separator for, let's say, end game solid state cell, you can't wind it at all. Yeah, so you need stacking to be future proofed.
Yes.
And then on the other hand, we did a lot to make the product more safe. That was driven by the battery system guys. but they were showing up saying, okay, we need to make sure the gases in the cell, whenever a cell has a problem, whenever a cell is opening, they have to leave the battery system at a certain place. With that,
controlled.
yeah,
in a controlled
and with
manner.
that you are on prismatic. Then you can forget pouch.
Yes.
Pouch is not able to do it. It will open somewhere, yeah, and you don't have a weak link where you can ensure it always opens there, yeah. And finally we had to make sure we can have highest performance and also lowest cost, and also there prismatic had a big advantage because we can cool just top side or no cooling. We can cool top and downside, and we can cool even between the cells if we have to, if we talk about an expensive Lamborghini, Bentley, Porsche.
Where the C rates really go up.
Yeah. If racing applications, all that is possible with unified cell.
So the unified cell will even be in the Lamborghini.
Yeah, it's possible. Yeah.
Okay.
Is there no? Can I say this? No, it's secret.
Maybe to give us
I'm not allowed to tell you.
Okay, good. Maybe in a future episode then.
But I would love to. This would
okay.
be a great company car, right?
Yeah, you could imagine. Understood the concept of the unified cell, and I think a couple of details about it. Looking from the production perspective, because I think one main lever is bringing the cost down on bringing this to as a successful product to the market. What are the levers that you pull from the production technology side? So talking about dry coating, for example, or other processes, what would you like to highlight there?
Yeah, dry coating is on top of the list, yeah, because it's consuming less energy, so you don't have to pay the energy you don't consume, and it's more sustainable, of course, yeah, to not use energy.
So the energy to all who may ask themselves right now is why? Because less solvent or no solvent in the end, finally.
Yeah.
Because we're right now in a semi-solid state, correct? And then we will remove all solvent, and the evaporation of the solvent is so energy intensive, and that is what is then the energy saving, correct?
Yeah, it's a whole process. Dry coating comes without any oven processes, right? It's just a pressing and calendering basically. Yeah, you can do it with plate pressing or with calendar pressing, different solutions. Ours is calendering, and that comes without an oven. And you don't have to install the oven, you don't need the space, you don't need the energy to run it.
Yeah.
Helps a lot.
Do you raise the temperature significantly?
No.
Interesting.
No, and maybe one day we invite you and show you what we do, but right now it's still relatively secret. Another thing is fast stacking. So we want to be as fast with stacking electrodes than we are with winding today. Yeah. And we have a concept for that one. It's not that far to production like the ones with dry coating, but we make good progress here. And of course, microenvironments will be very, very important for all cell suppliers in the future.
Yeah, I would like to touch on these points really quick. Can you give us an estimation on the frequency of the stacking? Just a ballpark?
Right now, we are at 0.6 seconds per electrode.
Yeah.
Yeah, and fast stacking will be 10 times faster. Yeah. Of course, it's not pick and place; it's rotating. Rotating helps because you don't have the acceleration and deceleration of the stacker, what consumes a lot of energy.
Yes.
If you just, rotate it, it's much less. Yeah, and so on and so far. Yeah.
I'm an engineer by heart, and all the pictures in my mind raise right now how you do it with the carousel, and I'm curious if you invite me to the plant one day to find out. Yeah, we will. Cool. So that question on the stacking, and then on the microenvironment, Saskia Wessel from Fraunhofer FFB, who I talked to yesterday and who is a colleague of mine from back in the days, also talked about the importance of that. How important is that from an energy point of view? So what is the order of magnitude probably that we can decrease the energy cost? Do you kind of give us an estimation there?
Yeah, 30%.
Okay.
In this process?
Yeah.
Electrode production process, 30%. Yeah. And to ask the Fraunhofer guys makes a lot of sense. These guys are good.
Okay, cool. So will this be all rolled out right from the beginning at all, like Salzgitter, Valencia, and all the factories?
No, we start with a conventional process in Salzgitter.
Yeah.
And the plan is to bring it 27, maybe in Spain, yeah, We will see. We
for the
haven't.
microenvironments you speak, no? Or for
No, dry
everything?
coating, dry
Ah,
coating,
okay,
dry
okay.
microenvironment. Sorry, Simon, I messed it up. So
No worries.
microenvironment. We haven't made the decision. Yeah, we haven't made
Okay.
the decision because it's relatively tough. You have to have a very robust production system to go that far.
Mm.
If you have to open up the microenvironment every hour, you can just forget it. Yeah, then you need a dry room. That's why everybody needs a dry room right now. So the whole logistics from material into the machine and final product out of the machine plus maintenance, that is the key to get there.
Yeah, I know how painful it is to open microenvironments. If you look behind you, there is the concept draft of CellFab. That's our little pilot line at eLab, and my PhD, where we decided to go for microenvironments to test this technology. And yeah, it's pretty cool to not have the influence of the operator anymore, the moisture that he emits. But if you have to change things, it's extensive because you have to open the mechanical part. Everything is a little more condensed.
Yeah.
So maintenance is difficult, or the conceptualization of the machines is more difficult. You have to work with drawers to get into the electronics, etc.
Yeah.
Understand you.
Yeah, absolutely. And of course, you produce scrap if you open it. Yeah. So if you're in a dry room, you can just run the rest of the materials through the process.
Yes.
And if you have, 50 cells already produce stacks or jelly rolls, that's a lot of money. Yeah.
Mm-hmm.
If you have to scrap these, then
Yes, I
that's a lot of money. It's expensive parts, especially the cathodes. Yeah.
Mm. Mm. Yes. Maybe if you can answer that question on the OEE. So if we talk about scrap efficiency and then finally sustainability, what do you expect in the end to be your OEE?
Well, that's complex, and process by process, it has to be on a high level to get to finally above 80, let's say, with the whole plant. Yeah. So every process has to be far above 90 to get there. Yeah.
Mm-hmm.
Of course. If you just have 2 and you want to be above 80, you have to be at 90. Easy.
Yeah. Yes.
But we work really with the best machine suppliers in the world. We buy what is proven technology. And especially in Asia, there are really turnkey solutions you can use, and they are having a real good performance. They have a good price. Yeah,
Mm-hmm.
I hope that the Western part of the world also will get into the business, but it's time and it's not easy. Yeah, because Korea, Chinese machine suppliers are doing a good job here.
Yeah, they are experienced, and in Europe we are just setting up everything to deliver the same at scale. I think that's the big issue. There are many manufacturers of good machines already, but to do it turnkey and on scale, I think that's
And on cost.
And on cost, okay.
Yeah, that's a hard one.
Okay. So would you say, reflecting the German machine manufacturers, from a technological point, they are there, but it's just too expensive yet?
No, I think even from technological point, it's still a way to go. Yeah, I like to see the efforts. I love to see what they do, how to get, how they work hard on getting there. But to get into, it's a bit like PowerCo. If you get into the game very late, of course, you have to do a lot of things right to be competitive.
Mm-hmm.
Yeah.
Mm-hmm.
We work with partners a lot. We also work with a development partner in China. Yeah, we have to be fast. We are not too proud to use what's there. Yeah, and if you want to do everything in house, everything different to the others, you will fail. Yeah, so it's probably a step-by-step approach. I'm sure especially the big machining companies in Germany can do it. Yeah, I'm convinced they can.
Yeah.
But it's not something you do and you print money after 5 years.
So you're basically not trying to be pragmatic, getting things done, rather than romanticizing the technological aspect of it. Rather focusing on, okay, we have to get there. Let's focus on the outcome.
Yeah. And to give you an example, in our LITEC, I was the CEO of LITEC for some years.
Yes.
In Kamenz, close to Dresden. We had Japanese machines in the front end, so the coaters, but the back end was completely German. Yeah, we had Saueressig calendaring systems, and we have these in our labs too. And we were using stacking and assembling for cells from Grohmann. Grohmann, in the meanwhile, was bought by Tesla. Yeah, so
Yes.
well, we need to do. If they have done it in, I don't know, 3 years. Yeah, so name it, Dürr, Grob, all these big companies, they can do it. They can do it. Yeah, they just have to focus and put the best people in, and then I'm sure they can do it.
Yes. Yes, we'll see. We'll see. And maybe they will also take a bigger part on closing the loop in the future, because I think that is something we all have in our minds, and the research, also at ELAB, for example, having the research projects set up that even the field. So do you see the European involvement on the equipment manufacturer side bigger? To help you closing the loop, because I saw in your presentation that this is also something that you really have on your agenda, correct?
Yeah, absolutely. Recycling is key to make the EVs more sustainable.
Yeah.
And if you do it right, you even have a cost advantage. That's how we see it, especially for NMC, for LFP probably not, for sodium probably not. But you have to do recycling. Yeah, you can't just send the cars to somewhere else in the world and leave them there. For the last years, yeah, and then you have to recycle. It has to be sustainable, and there's a great chance, because if you have an NMC battery in your car is 15 years old, you have 300,000 kilometers on it. You get money for it because nickel, lithium, cobalt is in it. Yeah?
Precious materials.
Yeah,
yes.
yeah, and if you then recycle it and do it well, you get the materials out, and you don't have to dig in the ground any longer to get the materials into the batteries.
Which also has positive political implications for Europe as
Absolutely. And we have companies who are able to do this. Our joint venture partner Umicore, where we do cathode materials, they do recycling already since decades. Yeah, there's a lot ongoing in China for recycling, and they do it also for good reasons, sustainability and cost. And it's probably a bit early, because a business case comes in 15 years with high volumes, but it's never too early. Yeah.
Yeah. So talking about the sustainability aspect, there's always the discussion of LFP, NMC. Recently, sodium came up. How do you see the evolution on the material side, also reflecting on the recyclability and sustainability of each and every technology?
Well, I think both LFP and NMC will stay. At NMC, you can focus a bit more on cost or on performance, so you probably have two variants. If you want to make high performance, you need silicon on the anode. Yeah, but that works best with NMC. If you can do it with LFP, but doesn't make sense, then NMC with the standard anode is cheaper. LFP will focus more on cost and cycle stability. Cycle stability, especially for stationary applications, is important, or trucks. Total cost of ownership driven, these two applications.
Yes.
And I think both will stay. I've seen in our lab cells, and others are working on that too, put manganese into LFP. Blending LFP with other materials is getting the level of energy density up.
Yeah.
And finally, the end game is a silicon, is an lithium anode. Yeah. So no graphite, no silicon, just plating the lithium at the anode. And I've seen this in our labs. It's possible. Yeah.
Okay.
It's technically feasible. A lot of people say this will never come. It is not that easy to industrialize it, but we are working on that.
Can you give us a hint on what is so challenging about it?
It's a complete different process of producing. You need, in our point of view, you need a ceramic separator. Yeah, you can't do it with any PPE or whatever. Even if you coat it, it has to be hard and very planar.
Yeah.
Yeah, and that is the one key, and then it has to mechanically fit to the anode foil, to the current collector. Yeah, and to make sure this works over 1,000 cycles is a challenge. But I've seen it. Yeah, it's possible.
Okay. So it's gonna be a race between LFP and NMC then. Sodium probably also because
both will stay. I'm sure both will stay. LFP is more cycle stability, cost of ownership. But if you drive your car, whatever, 200,000 kilometers, you don't need 5,000 cycle. You need 1,000. Yeah. So that then NMC is a good solution. Yeah. Sodium, well, so far lithium has to be really expensive to make the business case.
Like last year.
Yeah, that was the case. That's why some of the companies were investing into it. But I don't think sodium has to be above $40-50 per kilogram, and then it's a business case. And I don't think this will come. Lithium will not be on that level in average. If not, EVs will be sold much more, and then we will run out of lithium. The mines are getting short. Then of course the mines can price the material. Yeah, but that's probably. If then everybody goes to sodium, it will just turn around.
Yeah, of course. And if we may reference statements of that field, like the research there, sodium, even though it's from a sustainability point of view, currently sometimes an issue, the mining, in the long term, there are many solutions on the horizon that will, in my understanding, solve the problem of potential lithium shortage. Even in Germany, in the Rheingraben, we could mine lithium. So,
yeah,
gonna see. Frank, thank you. I would like to ask you two short questions in the end of this conversation. So one is, if you have to choose, what is the biggest bottleneck in battery innovation at the moment from your perspective? And it can be technical, economical, or even political. What would you come up with?
Well, if we want to go for high volume and we need volumes to be cost competitive, we need a predictable forecast of electric vehicles. Electric vehicles are scaling up lithium-ion batteries very much. Talking about stationary storage, that helps, but it's not on that scale. If we talk about, handies, whatever, it doesn't matter in the volumes. And for that, we really need predictable rules, political legislation setups, all over the world should follow the same logic. If this is not the case, it's difficult because it is a quite complex structure to build up lithium-ion business. If governmental regulation change from one to the next day, you can have a big issue with a big piece of money in an investment or whatever. Yes. Same is for cost of electricity. This is driving the business case also very much. Then all these things, I like that, sustainability rules, ESG, talking about supply chain Sorgfaltspflichtengesetz.
Yes.
Yeah. This all makes a lot of sense, but it has to apply all over the world. If not, we will have more to do.
There's no common playing ground.
Right.
Yeah.
And then this would lead the industry to invest in other countries or let the other players do the game alone because we are busy with other things. Yeah.
With our regulations.
Yeah, it is very, very important that the new world of EVs will follow the same rules all over the world, or we have other restrictions to play it fair. Yeah, this is driving us a lot. Yeah, but all the decisions we have made so far, we would have made even if everything would be the complete opposite of what it is today. So far, it's all right, but now I think it has to all be more predictable and more, comparable all over the world.
I understand you. And on the positive side, so what would, from your perspective, be one thing that really makes you smile, like the potential that you see on the horizon, like one thing that really stands out?
I can tell you whenever I talk to our people, whenever I'm in touch with the guys in the labs, in the production sites, people showing us the board of PowerCo proudly what they achieved. This gives me a lot of motivation. Okay. We just had the board of Volkswagen in Salzgitter, and our people presented what they achieved, and I was not saying anything. I was just supporting. And to see how proud they are, what they can do, how you know, how good they feel in Germany. People from a lot of different countries working together. You know, the kids are playing together. They know each other.
Oh.
That is cool. That makes me a lot of. That makes me proud and gives me a lot of motivation on top of all the other things.
Wow, yeah, it sounds really good and reflective of the dynamic of our current industry. How everyone tries to figure out how we best can work together and collaborate. So, Frank, thank you very much for the conversation. It was a pleasure.
Thank you, Simon.
And see you then at one of the factories in the future.
Yeah, we will. Thank you very much.